Hello, my name is Keith Larson with Control and Control Design Magazines, and I'm here at GE Intelligent Platforms Connected World event here in Chicago. They're in the midst of a worldwide tour, really unveiling what their latest thinking is around the Internet of Things and Internet of Machines specifically, and how that applies to industry. And with me today here is Bernie Anger. He is General Manager of Control Systems and Communication for our GE Intelligent Platforms. So thank you for joining me, Bernie. A real pleasure to be here.
Keith, always good to see you.
I'll just have a few questions to talk about your vision around the Internet of Things. Last week we had Jeff Immelt was here in terms of a broader Mind and Machines event, but this one's much more focused specifically on GEIP's take on things. Maybe just to set the context, maybe you could talk a little bit about what you see in terms of some of the pressures that are shaping industry now in the manufacturing and energy industry today.
Yeah, so I'm probably going to give you a slightly narrower answer. So instead of telling you what are the problems affecting everybody, I'll take this thing from the perspective of equipment manufacturers, just because that's a place where you can think about GE as an equipment manufacturer, as an OEM, and many of our customers are equipment manufacturers in turn, right? So, for starters, the obvious one, everybody's competing on a global scale, and everybody's looking at how to differentiate, based on that sort of global competitive landscape. At the top level, I think equipment manufacturers are trying to figure out how to do any combination of one of three things: getting closer to their customers, getting a high degree of intimacy with the customers, finding out ways of enhancing the performance of the assets they make, and/or coming up with new service models that create new revenue streams for them, right? And as they try to do that, really they're doing that in an environment where the equipment, as it goes to their end user, has a new set of expectations, right? The first set of expectations around this whole idea that not only can you sort of ship a machine and forget it, but you have to sort of ship and support it, because your customer likely is running with a skinnier support crew. Sure. Number two is that that personal experience, that device that you're carrying in your hand, it has raised the bar in terms of our expectation of what we can do from where, when. We want access to everything, everywhere, to make the right decision, at the right time. So that's actually really changing a little bit of the expectation of the end users as well. And the third challenge is, how do you marry very different life cycles? So if you may think about a turbine GE ships that is expected to run for 20 years. Well, the technology that's running that turbine probably has an upgrade cycle that could be significantly shorter of that if you want to take advantage of advances in technology to get additional asset performance. So the grand scheme is, hey, you got people on a global scale, regardless of their scale, regardless of their size, because this applies to the small OEM and to the massive OEM like GE, competing globally with changing expectations on their side of their customers. Now, there are tremendous benefits that can be enabled by some of the technology applied to that problem as well. So this is not a doom and gloom type of scenario. Right? So
what are some of the technologies being brought to bear to help tackle some of those issues then?
Yeah, so at a conceptual level, probably the biggest thing we're proposing is this whole concept of leveraging some of the technologies that were initially developed for the commercial internet, and then hardening, by lack of a better term, and utilizing them in the industrial world. I know you've actually heard the term industrial internet, and I often get asked, what does that actually mean, right? So GE uses the term industrial internet to really talk about three things working in concert. The first one is what we call brilliant machines, the second one, which is what we call advanced analytics, and the third one, people at work. So what does that actually mean? Brilliant machines are machines that can adapt to the environment that they run in. Advanced analytics are really the engines that allow us to understand how things are running and how could they run, and use that information twofold. One is to feed back to those machines, and number two is to provide the right information at the right time, and just that to the operator so they can make the right type of decision. Right? And that's really at a high level what underscores the investments that we're actually making, because the majority of what we're spending money on is enabling that, making that actually possible for us as a producer of platforms, and for us as a consumer of those platforms inside of the General Electric company.
Yeah. One of the big differences between the commercial technology space and the industrial side is the length of the life cycle. So you put in a machine and you're expected that controller to run for the next 10 years or 20 years, or in a refinery 30 or 40 years. How do you address that kind of discontinuity between those expectations and what's possible on the consumer side versus what the expectations are from the control industry, where the expectations are a little more conservative.
You know, that is probably the biggest challenge. The way I like describing the way it's a rational challenge is if you think about the dollar value of a control system relative to the asset it's controlling, it's really, depending on your machine, 2 to 10%, right? And then if you think about that relative to the value of production that runs through, it's really nothing.
Almost nothing.
So when you think about making a decision, it's very easy for the downside of risk to outweigh the benefit of the improvement, and that's why when you go around you see so many systems that are running with 20-year-old technology now. Our industry is pretty good about making things that run for 20 and 30 years, so I don't think there's a risk in running old things. There's just a missed opportunity issue. So the way we're thinking about this thing is, hey, listen, how do we decouple the various elements of a control system, right, so they can be sort of replaced while in operation, right? So, and we have a lot of concepts that we're working in there. One is, we talked, and we encourage our customers to think about Ethernet as a backbone to everything they do. So think about Ethernet as a new backplane, if you want, just because it actually creates the most resilient platform to upgrade pieces one at a time. But then we're working with advanced concepts as well. So probably the more exciting one at the machine level is this concept of software-defined machines. So rather than the historic paradigm where you had the control device and its software fairly closely intertwined with each other, we're really looking at things from a perspective where we have sort of self-contained control devices that are purely software-defined, and then we actually host them on hardware platforms. The cool thing about doing that is you can host them in the traditional way at a control system at a machine, which is probably what you do to run the machine. You can also host them on server farms, etc., for simulation, for testing, for validation, for all kinds of other things. So what we're really trying to do behind all of this thing is not a science experiment, but really, is there a slightly different architecture that allows you to modify the machine without adding risk to the machine? Because the benefit is huge. If you think about closing the loop, you design a machine, you put it into operation. You use analytics to understand how it's actually running. You learn from that to tune the way that machine is controlled. If you can feed that back down, you can take the exact same physical asset and get a new level of performance, and that has real economic value for customers. The trick is to do it safely, and that's what we're focused on.
It seems it really opens up some opportunities for leveraging some of the collaboration tools and other things to be able to bring some intellectual property from over here and bring it together and download it to a machine in a relatively seamless but safe fashion.
When you use the word collaboration, you sort of tickled my favorite chord there. I pretty much everywhere I look, whenever collaboration takes hold of a space, it really redefines how people compete, right? And if you start observing that, you see it in multiple places. We actually think that in the way we think about automation, primarily in the context of industrial internet, is all around networks of partners. Now, you saw GE announce sort of large partnerships with some of the, I'm going to call it infrastructure providers, so that'd be AT&T and Cisco and so on. And I think those are necessary, but we really see a future where getting to optimal is a combination of small and large partners, right, working against a common platform, a common architecture, and that's really what we're investing in.
Makes a lot of sense.
Collaboration, it's impossible to beat the speed of a collaborative environment once that takes hold.
No, that makes a lot of sense. So what else can we look forward to in the coming months from GE Intelligent Platforms? Any things we should be on the lookout for making this industrial internet
So
real?
you and I have had the opportunity of chatting over the last couple of years, and I think probably the transformation you're starting to see is what started as an intellectual conversation 2 years ago is now increasingly a conversation about, hey, let me show you where it's actually being done. Right? And probably the biggest thing you're going to see from us is, of course, you're going to see injections of technology that become product. That's kind of the nature of the industry. But the probably more interesting thing you're going to see is an increasingly large stream of examples where the industrial internet is actually creating value for customers, actually affecting outcomes for customers. And we see that in small standalone applications, we see that in large network systems. So I look forward to sharing those with you over time. I think that makes it viable for customers.
Well, and of course, that's what our readers and viewers are always looking for, case studies, examples of how people are really putting this stuff to work.
Well, that's cool.
That's great. Looking forward to hearing more. Again, Keith Larson with Bernie Younger here at the Connected World event in Chicago. Thanks for tuning in.